Very good morning, students. Today we continue our Fourier series chapter with the topic discontinuous function with the limits 0 to 2 pi. Okay, so let's start with the example. Suppose your given question is find Fourier series of f of x is equal to -1, 0 less than x less than pi and is equal to 2 if pi less than x less than 2 pi, right? So students, again we have to find Fourier series and our given function is discontinuous function. Our function is discontinuous at pi, right? So for 0 to pi our function is -1 and for pi to 2 pi our function is 2. In this case, we apply the same formula of f of x is equal to a0 by 2 plus summation n 1 to infinity an cos nx plus bn sin nx. And then we start with our a0, that is 1 by pi, here 0 to 2 pi f of x dx. Students, some students ask me through WhatsApp and through chat that in book there are 1 upon 2 pi, right? In book there are 1 upon 2 pi. But in that case, in original function there is a0 only, there is o0 only. But I apply a0 is equal to 1 by pi, so we are applying in main formula a0 by 2. So both are correct. In McGraw-Hill they apply only a0 and they apply 1 by 2 in the formula of a0. Okay, so here we continue. a0 is equal to 1 by pi 0 to 2 pi f of x dx, right? So wait a minute, someone has, okay. So here 1 by pi, here 0 to pi, for 0 to pi function our value, our function is -1, f of x is -1, right? And for pi to 2 pi our function is 2. 1 by pi is common, so 1 by pi, this -1 is constant, so integration of 1 with respect to x is just x, limits are 0 to pi. Similarly here 2 is constant and the integration of 1 with respect to x is just x and the limits are pi to 2 pi. I think no one has any doubt in this step. Now a0 is equal to 1 by pi, right? And after substituting upper limit minus lower limit, pi minus 0, that is just pi, so minus pi plus 2. Here if we substitute upper limit minus lower limit, that is 2 pi minus pi, 2 pi minus pi. Okay, so after simplification, here minus pi, this is 2 pi minus pi, that is just pi, but here 2, so 2 pi and 2 pi minus pi again, so pi by pi, right? And pi by pi is 1, so our value of a0 is 1. Value of a0 is 1. Okay, is there any doubt to anybody for the value of a0? Okay, so let's move with the another value. Okay, so let's move with the another value, that is an, right? The formula of an is 1 by pi 0 to 2 pi f of x dx, And as we know that our given function is discontinuous, so for 0 to pi, our function is -1, and for pi to 2 pi, our function is 2. Okay, and oh, sorry, I forgot to write the cos nx. So this is the formula of, here the formula of an is 1 by pi 0 to 2 pi f of x cos nx dx, right? Now 1 by pi, for 0 to pi our function is -1, so -1 cos nx dx plus pi to 2 pi, our function is 2 into cos nx dx. Okay, now 1 by pi, -1 is constant, so the integration of this cos nx is just sin nx, so minus here sin nx upon n, and the limits are 0 to pi. Here this 2 is constant, so again the integration of this cos nx is sin nx upon n, and the limits are pi to 2 pi. Okay, now 1 by pi, if I substitute the upper limit, that is sin n pi, and as we know that sin n pi is 0, so 0 upon n is 0, and if we substitute lower limit, that is sin 0 is also 0, so both the value 0 plus 2. If we substitute this 2 pi, then sin 2n pi. Sin 2n pi is again 0. So 0 upon n is 0, and sin n pi also 0. So all the values are 0. So 1 by pi into 0, and 0 upon pi is 0. So an is 0. So the value of an is 0 here. Right? Now, for the value of Bn. For Bn, formula of Bn is 1 by pi 0 to 2 pi f of x sin nx dx. Same as an, so 0 to pi, our function is -1. This one is sin nx dx plus pi to 2 pi, our function is 2 into sin nx dx. Okay, now 1 by pi, this -1 is constant. Okay, and the integration of sin nx is minus cos nx upon n, and the limits are 0 to pi. 2 is constant, so integration of this minus sin nx is minus cos nx upon n, here pi to 2 pi. Okay, so after substituting the limits, this minus minus plus, so our first cos n pi, and what is the value of cos n pi? Cos n pi is minus 1 raised to n. Please remember, cos n pi is minus 1 raised to n upon n, minus cos 0. If we substitute 0, then cos 0 is 1. So 1 upon n. This is for the first term. Now plus minus is minus, so minus 2. If we apply here the upper limit 2 pi in the x, then cos 2n pi, which gives the value 1, so 1 by n, and minus cos n pi, if we substitute pi in the place of x, cos n pi, which gives minus 1 raised to n upon n. Students, please remember, cos n pi is minus 1 raised to n, cos 2n pi is 0, cos 2n pi is 1, cos 0 is also 1. Okay, so and sine, for sine, pi and pi 2 and pi sine 0, all value are 0. Okay, so it will help you. These values help you for the solution of the example. Now, after simplification, I have minus 1 raised to n upon n minus 1 by n, this one minus 2 by n, and here minus minus plus 2 minus 1 raised to n upon n. It means the first and last term are same. So 1 plus 2, that is 3 minus 1 raised to n upon n, and this one is minus 3 upon n. So if I get 3 common, 3 by n common, then I have 3 n pi, and in the bracket this one minus 1 raised to n minus 1. Okay. Have you any doubt? Have you any doubt in the value of the Bn? Okay. So, okay. Now, the last step of our example, that is f of x a0 by 2 summation n 1 to infinity an cos nx plus bn sin nx, right? Now, as you know, the value of a0, that is 1. Value of a0 is 1, an is 0, and bn is this one. Value of bn is what? This is 3 by n. Value of bn is 3 upon n pi minus 1 raised to n minus 1. Okay. So, here value of a0 is 1 by 2 summation n 1 to infinity. Here 0 into cos nx, that is 0, so no need to write this stuff. Now the value of bn, and the value of bn is 3 upon n pi, here minus 1 raised to n minus 1 into sin nx, right? So 1 by 2, we keep this 3 by pi, here minus 1 raised to n minus 1 is so no, this contain n, right? So summation n 1 to infinity minus 1 raised to n minus 1 upon n into sin nx. This is the Fourier series of the given questions. Students, have you any doubt? Okay. So let's move with one more example. Okay. So let's move with one more example, that is please repeat the last step. Okay. This one, Kashyap. In last step, here I substitute the value of a0, that is 1 by 2. Value of an, that is 0. So 0 into cos nx is 0. So no need to write this step. And the value of bn, and value of bn is what? The value of bn is 3 upon n pi minus 1 raised to n minus 1. So here I put 3 upon n pi minus 1 raised to n minus 1. This is the value of bn into sin nx. Okay. So these 3 upon pi are constant, which is free from n. So I put out of the summation. So 3 upon pi, and the rest of things minus 1 raised to n minus 1 upon n into sin nx, that are in the summation form. Okay. Thank you. Now, let's move with one more example. That is, suppose our given question is Again, I am taking one more discontinuous function, then we move for the even odd function. Okay, so this is the last example for the discontinuous function. Suppose our question is find Fourier series of f of x is equal to minus pi, here 0 less than x less than pi, and the other function is x minus pi, that is for pi less than x less than 2 pi. Students, our overall integral is 0 to 2 pi, but the given function is discontinuous at pi. Okay, so let's start with the solution. Our main formula for the Fourier series, that is a0 by 2 summation n 1 to infinity an cos nx plus bn sin nx, right? Now the formula for a0 is 1 by pi 0 to 2 pi f of x dx. Okay, so 1 by pi, this one 1 by pi, for 0 to pi my function is minus pi, so minus pi dx, and for pi to 2 pi my function is x minus pi, right? And 1 by pi is common. So as this minus pi is constant, the integration of 1 with respect to dx is x, and the limits are 0 to pi. Plus, now the integration of this term with respect to x, so the integration of x is x square by 2 minus pi x, and the limits are pi to 2 pi. Okay, so 1 by pi, here minus pi. If I substitute upper limit minus lower limit, that is pi minus 0, so it is pi. Plus, if I substitute the upper limit, that is x square, so 4 pi square by 2 minus, this one is 2 pi into pi into 2 pi, that is 2 pi square. So this is for the upper limit. This is for the Devanshi. Ma'am, can you please go bit slow? Okay, okay, Devanshi. See, ma'am, roll number 12, Krupali, joined with one device. There are two names showing with the same roll number and name. Roll number 12, please join with one device only. Okay, Devanshi, I'm trying to go slow. Okay. See, students, here the integration of this minus pi is constant. So integration of 1 into dx. So integration of 1 with respect to the x, that is x, and the limits are 0 to pi. Okay. Now the integration of this x is x square by 2 minus the integration of this pi is constant, so pi into x, and the limits are pi to 2 pi. Okay. Now minus pi, keep it same. If I put upper limit minus lower limit, so upper limit is pi minus lower limit, so pi minus 0 is pi. Okay. So this is for the first term. Now for the second term. For second term, first I substitute my upper limit in both terms. So if I substitute upper limit 2 pi in both terms, then 4 pi square by 2 minus 2 pi into pi, that is 2 pi square. So here I substitute my upper limit in both terms. Now minus I am substituting this lower limit in both terms. So pi square by 2 minus pi into pi, that is pi square. Okay. So 1 by pi, this is minus pi square. Here 2 pi square minus 2 pi square, so my second term will be 0, minus pi square by 2 minus pi square, so this is minus pi square by 2, right? Now this minus minus plus, so minus pi square plus pi square by 2, so my answer will be minus pi square by 2, and 1 pi will be cancelled, so my final answer is minus pi by 2. Students, again minus pi into pi, that is minus pi square, second term will be 0, and for the last term my answer will be minus pi square by 2, but this minus plus, so minus pi square and plus pi square by 2, so minus pi square plus pi square by 2, so my answer is minus pi square by 2, 1 pi will be cancelled, so final answer is minus pi by 2. So the value of A0 for the given question is minus pi by 2. Have you any doubt? Have you any doubt? Devanshi, now are you okay with my speed? Okay. Devanshi, now okay? Devanshi, I ask you, roll number 52. Are you okay with my speed now? Okay. If still any student have any doubt with according with speed or for any kind of, then please write in the chat box. Okay. Okay, students. So this is the value of A0. Now we'll move for the value of AN, right? So AN 1 by pi 0 to 2 pi f of x cos nx dx. So this is the formula for AN. Now 1 by pi, as we know, the value for the 0 to pi, that is 0 to pi, that is minus pi. So minus pi cos nx dx plus pi to 2 pi, that is pi x minus pi cos nx dx. Okay. Now 1 by pi, this minus pi is constant, so integration of this cos nx is sin nx, so minus pi, this one is sin nx upon n, and the limits are 0 to pi. Students, here we are doing the integration of this first term, minus pi is constant, so the integration of this cos nx with respect to x, that is sin nx upon n, and the limits are 0 to pi, right? Now plus integration of this for the second term, integration for the second term, this is u and this one is v. Okay, so now we are going to apply Leibniz rule. So x minus pi, keep it same. The integration of this cos nx is sin nx upon n minus the derivative of this x minus pi is 1, and the integration of this sin nx is minus cos nx upon n square, right? And the limits are what? Pi to 2 pi. Now the derivative of 1 is 0, so no need to move again. Now 1 by pi. Okay. Now if we apply upper limit and lower limit, this is 0, right? Upper limit and lower limit in this function. So the first term is sin n pi, And as you all know, sin n pi is 0. And if we apply lower limit, that is sin 0. Sin 0 is also 0. So minus pi, my upper limit and lower limit both gives the 0 value. Okay. Plus, now for the second term. Here, if first we apply 2 pi in both term and then we apply pi, that is the lower limit. So, if we apply sine 2n pi, then sine 2n pi is 0. So, 2 pi minus pi is pi, but pi into 0 is 0. So, first value after applying upper limit is 0. Minus minus plus cos 2n pi. Cos 2n pi is 1. So 1 upon n square. Students, this is the value for the second term for the upper limit. When we apply my upper limit, sin 2n pi is 0 and cos 2n pi is 1. So 1 upon n square. Now minus. Now I am going to apply this lower limit. So this pi. So pi minus pi is 0 and sin n pi is also 0. So this one is 0. Minus minus plus, right? Now cos n pi is minus 1 raised to n upon n square, right? So 1 by pi, this one is 0, here 1 upon n square, here minus 1 raised to n upon n square. So if I keep n square as a constant, then the answer is an is equal to 1 minus 1 raised to n upon pi into n square, right? So this is the value of an. Now for the bn. Here bn 1 by pi 0 to 2 pi f of x sin nx dx. Okay, and same as an for 0 to pi, here minus pi sin nx plus sin nx dx plus pi to 2 pi, here x minus pi sin nx dx. Okay, so for bn 1 by pi, as minus pi is constant, the integration of this sin nx is minus cos nx upon n, right? And the limits are 0 to pi. Plus, again, the integration of this second term, again we are applying Leibniz rule. So x minus pi, keep it same. The integration of this sin nx is minus cos nx upon n minus the derivative of this x minus pi is 1. Now the integration of this minus cos nx is minus sin nx upon n square. Students, as per my experience, integration is easy, but when you are trying to apply the limits, students make more mistakes when they apply the limits. So, when any faculty can do the example, the students thinking that it is very easy, but when you are trying your own self without textbook, then there is a chances for the mistake of the sign. So please do yourself at home. Otherwise, if you cannot practice, then there will be chances for the mistake of plus or minus sign. Okay. So the minus minus plus, right? If I apply upper limit, that is cos n pi. So cos n pi is minus 1 raised to n upon n, and here cos 0 is 1 upon n, right? So this is the value for the first term. Now for the second term. Students, have you any doubt? Have you any doubt till this step? Okay. Now if I apply my upper limit, so here x minus 2 pi. Please be careful. It is x minus 2 pi. 2 pi minus pi, that is pi, cos 2n pi, that is minus 1, minus sign is there, so minus 1 upon n. Here minus minus plus sin 2n pi. If I apply my upper limit, sin 2n pi, that is 0, right? So this is the value of the upper limit. Now minus, if I apply my lower limit, then pi minus pi, that is 0. Cos n pi is minus 1 raised to n, but this 0 into anything is 0, so 0 plus sin 0 is also 0, right? So here 1 by pi minus pi minus 1 raised to n minus 1 whole by n. I keep both term different, so it is minus 1 raised to n upon n minus 1 upon n, and if I keep this pi as common here, then this is again minus 1 upon n, right? And the rest terms are 0. So both pi will be cancelled, and my answer is here minus 1 raised to n. This is minus 1 by n and minus 1 by n, so minus 2 whole by n, whole by n. Now this is the value of the Bn. Diya, what is your doubt? Ma'am, what are the answer to homework question? Diya, will discuss it later, okay? First we conclude this question. So this is the value of Bn. Now we substitute all three value in the main formula, that is a0 by 2 plus summation n 1 to infinity an cos nx plus bn sin nx, right? So what is the value of a0? And as you all know, the value of a0 is minus pi by 2. See, the value of a0 is, see, minus pi by 2, right? See, this is the value of a0. So minus pi by 2, here 1 minus minus 1 raised to n upon pi n square, and this is the value of bn. So this is minus pi by 2 into 2, so minus pi by 4 plus summation n 1 to infinity, the value of an, that is 1 minus minus 1 raised to n upon pi n square, upon pi n square. This is the value of an into cos nx plus summation n 1 to infinity, the value of bn is minus 1 raised to n minus 2 upon n into sin nx. Okay, so this is the Fourier series for the given question. So students, today we discuss this for the Fourier series for the discontinuous function. Have you any doubt? Please confirm in the chat box. If no, then we move for the next topic, that is even odd function. Okay, thank you. So answers are coming that the students have no doubt, right? So now we are moving for the even odd function. Just one, Dhruv Bhausar. Here do we have to replace f of x with functions? It's up to you. if you want to replace f of x with your function, then, and if you no need, okay, it's up to you. Neil Jani, can we put the value in cos nx? No, no. In see, Neil, when we apply the value of a0, an and bn, then in final formula, no need to put the value of cos nx. See, value of cos nx, it depends on the value of x. So there is no particular value of cos nx. Okay. So in final formula, you have to just keep cos nx and sin nx as it is. No need to put the value of cos nx. Okay. Have you any doubt? I think now your doubt is clear. Okay, Neil? Okay. So, students, now move with one most IMP topic, that is even odd function. Okay. This is the most IMP topic for the example. Now, suppose first we start with what is even function. So any function, a function f of x is said to be even function if f of x is equal to f of minus x. Okay. Example, x square cos x mod x. See, if x square and minus x whole square both are same, cos x and cos minus x both are same, mod x, mod minus x, right? So these are the example of even function. And same for the odd function. A function f of x is said to be odd function if f of x is equal to minus f of minus x, or we can say f of minus x is equal to minus f of x. Okay. If function satisfies this condition, then that is known as odd function. So example of odd functions are x, x cube, sin x, like this. Okay. In this case, x and minus x. So that satisfies this condition. X cube and minus x cube. Similarly, sin x is equal to minus sin minus x. Okay. So students, when your function is even or odd, then there is a formula for the integration, that is for the, if your function is even or your function is odd, then, and your limits are, please remember, if your limits are minus L to L, okay, if your limits are minus, L is any number, minus 1 to 1, minus 2 to 2, or we can say minus pi to pi, minus L to L, f of x dx, then we put 2 times 0 to L f of x dx, and if your it is applicable when your function is even, okay, for even function f of x, and for odd function f of x, minus L to L f of x dx, your direct answer will be 0. Okay. So please remember, for even function, if your limits are minus L to L and your function is even, so you can write 2 times 0 to L f of x dx, and if your function is odd, then for and if your limits are minus L to L, then f of x dx is equal to 0. One more thing, students, even into even function is always even. Odd into odd is also even, right? But even into odd is odd. For even plus odd or even minus odd, we can't say. Okay, it will be neither even nor odd functions. It will be neither even nor odd functions. So, by using this formula, we modified our Fourier series formula. So, for Fourier series, and even odd function, Fourier series for even odd functions. So, for even function, this is the most IMP thing which I am going to tell you. Please remember. And odd functions. For Fourier series, if your function is even and your limits are Fourier series for limits minus pi to pi. Okay, I am taking the period minus pi to pi. Students, the most IMP thing, you convert your function into even or odd function if your limits are minus L to L. Okay, if I give you function f of x is equal to x square, and if I give your limits 0 to 2 pi, then this x square you cannot convert into the even function. Your limit must be minus pi to pi, minus 1 to 1, or in general I can say minus L to L. Then and only then you convert your function into even or odd. If your period or limit start with the 0, then you cannot convert your function into even function or odd functions. Got it? So, this is if your function is even, then you have to directly write Bn equal to 0, and the formula of A0 is 2 by pi 0 to pi f of x dx, and formula of An is 2 by pi 0 to pi f of x cos nx dx. Similarly, for the odd function, if your function is odd, your limits are minus pi to pi. Please remember, if your limits are minus pi to pi, then a0 is equal to an equal to 0. Okay, you have to just find bn, that is 2 by pi 0 to pi f of x cos nx dx. So, as per this, your final formula for even function is a0 by 2 summation n 1 to infinity an cos nx. Okay, here bn is 0, so no need to write the bn sin nx. Similarly, for odd function, your final formula is summation n 1 to infinity bn sin nx. Okay, because here a0 and an are 0. So, for even function bn0, you can directly write bn, no need to find the value of bn. And for odd function, no need to find the value of a0 and an. Okay. So, have you any doubts, student? Oh, yes, yes. Students, here, by mistake, I write here cos. This is the sign. This one is sign. For bn, this is sign. Okay, yes. This is not so. This one is sign. Right. Okay. By mistake, I write here cos. For an, cos, but for bn, sin nx. Okay. Okay. So now, have you any doubt? So we'll continue. What Mahir? What for half range? Mahir, half range is the different thing. We'll discuss that when we in the letter. We'll discuss it later because the half range is the different topic. Okay, this is for the even odd function. So, have you any doubt? Okay, so you can leave our today's meeting. We'll continue tomorrow with the example of even odd function. Okay, ma'am, limit like pi by 2 or like that. Mahir. Okay, Mahir, if your limits are pi by 2, then you have to put the value of pi by 2. If your limits are minus pi by 2 to pi by 2, then you convert your function in even or odd. Okay, if your limits are 0 to pi by 2, then you have to put your values for 0 and for pi by 2. You have to solve like 0 to 2 pi as we solve previous examples. Okay, got it, Mahir? So thank you, students. You may leave now.